A 4-ton metallic cylinder, the size of a 5-story building, is tumbling silently through the vacuum of space. It is hurtling toward the moon at 5,400 miles per hour. On August 5, 2026, it reached the surface. The collision released the explosive force of 3 tons of TNT, gouging a fresh crater into the lunar rock. This was not a natural asteroid. It was human-made space junk, specifically a spent Falcon 9 upper stage built by SpaceX. Before we dive into how this happened, drop a one-word description of space junk in the comments below. This accidental collision acts as a stark case study for the region beyond our atmosphere. It highlights the growing complexity of a space where discarded hardware can transform into an unguided projectile. This rogue rocket began its journey in January 2025. SpaceX launched it to deliver 2 lunar landers, but after separation, the second stage lacked the fuel to escape the Earth-Moon system or return home. For months, the rocket was caught in a gravitational tug-of-war. Its path loops erratically as Earth, the Moon, and solar radiation fought over its trajectory. This instability forced a collision course, pulling it toward the lunar far side, impacting near Einstein crater. For scientists, the speed of the impact was key. Most meteorites strike the moon at roughly 16 kilometers per second, but this human-made object was traveling at a relatively slow 2 to 3 kilometers per second. This difference turned an accident into a rare, free experiment. Researchers were able to use this controlled collision to study exactly how lunar craters form and how dust behaves in low gravity. Capturing the data wasn't easy. No satellites were in the right position to photograph the impact as it happened, meaning we have no direct visual of the crater forming. Instead, evidence came from the ground. Astronomers at the European Southern Observatory in Chile used their telescopes to track the aftermath from Earth. They detected a massive dust plume kicked up by the crash. In the moon's airless environment, that debris cloud lingered for nearly 10 minutes. Chemical analysis of that plume provided the fingerprints of the crash. The data visualization shows sodium signatures from the lunar soil, but it also isolates lithium, a direct signature of the rocket's own hardware. While scientists were thrilled to have this data, space lawyers were deeply concerned. The crash exposed a regulatory gap that threatens the future of exploration. On the moon, there is no atmosphere to drag down flying particles. In a frictionless vacuum, impact energy drives debris into a high-velocity spray that can travel for kilometers across the surface. This shotgun effect creates a major safety risk. A single, uncoordinated crash could send debris into the path of multi-billion-dollar satellites or damage the nuclear-powered bases currently being planned for the lunar surface. It also threatens unprotected historical sites. A stray impact nearby could easily erase the 1969 Apollo landing footprints, destroying evidence of humanity's first steps on another world. Currently, the 1967 Outer Space Treaty is our primary legal framework, but it was signed in a time when only governments went to space, and it lacks the specific rules needed to assign financial liability for damage caused by private companies. This leaves the moon in a state of legal uncertainty, a place where a runaway rocket can strike the surface without a clear path for anyone to be held responsible for the damages. Knowing these risks, would you ever consider living on a commercial moon base? Type yes or no in the comments. To solve this, experts suggest we don't need decades of new debate. We simply need to put the existing laws to work, specifically Article 11, which calls for transparency in space activities. The first step would be a lunar registry. This database would track all incoming hardware and provide legal protection for scientifically or culturally significant sites. We also need a system of notices to lunar operators. These would warn anyone on or near the moon about incoming hazards or dust-generating activities before they launch. We already use these systems. Pilots rely on notices to airmen, and captains use notices to mariners to navigate safely. As commercial spaceflight continues to expand, we must set these basic traffic rules now. If we don't, we risk turning the moon into a permanent cosmic junkyard. Help us spread the word about protecting lunar history by sharing this video. If you want to see what happens when NASA crashes a spacecraft on purpose to save the Earth, click the video on screen to see the DART mission. Thanks for watching.